Let's see how to carry out a dynamic seismic analysis in CYPE-3D. To do this, in the Project menu at the top of the interface, we select the General Data option. Then, in the Loads section, we activate the With Dynamic Earthquake Loading checkbox. This takes us to the configuration window of the code for the calculation of seismic loading. First, we mark the country or region in the list on the left-hand side. This will display the codes associated with each of them in the top right-hand corner. We can also choose the general method, which allows us to define a customized seismic spectrum. In this example, we choose EU and Eurocode 8. By selecting the desired code, we can configure the related parameters using the rest of the options in the window. Further on, we activate the corresponding checkboxes to indicate that we want to perform the analysis of seismic action in direction X and seismic action in direction Y. In the analysis parameters, we enter the fraction of live load and the fraction of snow load used to evaluate the mass of the building during an earthquake. Then, we describe the structural system of the job. Its height geometry can be regular or irregular. To enter the behavior coefficient in X and Y, we can rely on the information provided in the Help button. Here, the program shows recommended values for this factor depending on whether it is a concrete, steel or composite structure, on the type of structure, and on its ductility, which can be medium or elevated. In location data, we enter the type of spectrum, which depends on the magnitude of the surface waves of the earthquakes recorded in a specific area. We click on the Help button again to consult the information. Below, we type in the peak acceleration, expressed as fraction of the gravitational acceleration, g. Then, we must define the soil type and the importance of the job by marking the corresponding options. The program offers some information texts when selecting each of the options that help us to define the case of the job. Now, we can click on the button at the bottom to check the automatically generated design spectrum with the marked options. In the dynamic modal spectral analysis, we must include all the modes that contribute significantly to the dynamic response of the structure. For this purpose, in the following section, we indicate the number of vibration modes considered in the analysis. When defined based on the code, the program calculates the number of modes needed to comply with the specifications of the chosen seismic code. If it is automatic until a required percentage of displaced mass is reached, we must enter this percentage, which will normally be high, to ensure that the analysis is relevant. If the number of modes is specified by the user, we directly enter the number of modes based on our own considerations. The number of modes influences the analysis time and should not be increased uncontrollably, but it should be enough to ensure that an adequate percentage of displaced mass is reached, which we can check in the reports. As for the effects of the vertical seismic component, we can mark Do Not Consider It in most cases, but if desired, we can consider it and mark Specify the modification coefficient that increases or decreases the permanent load factors in the seismic load combinations. We click on the Help button for more information on the consideration of the vertical seismic component effects and the value adopted by the modification coefficient. By default, the program performs the analysis without second-order effects. If desired, we click on the button at the bottom to open a configuration window and activate the box that appears to consider second-order effects. The program will use the p-delta method in order to estimate these effects. We also enter the value to multiply displacements, which, in the case of steel column structures, can be equal to 1. From here, we can also check the amplification factors of the horizontal loads, corresponding to the last analysis of the structure. Once the configuration of the seismic code has been completed, we click on Accept to return to the General Data window. Returning to the Loads section, we can now define the criteria of reinforcement by ductility in the process for designing concrete columns and beams by choosing Low, Medium, or Elevated Ductility in the drop-down list. A detailed description of this criteria can be found by clicking on the Help button on the right. When we click on Accept, we return to the program's general interface. If we have completed the definition of the model, we click on Analysis. The program carries out the seismic analysis by means of a complete spectral modal analysis that solves each mode as a load and carries out the modal expansion and modal combination to obtain the forces. Once the model has been analysed, we open the Analysis menu and check the specific report with the information about the dynamic seismic loading provided by the program. This report shows, first of all, the earthquake general data. It then includes the definition of the design acceleration spectrum, the design spectrum according to X, and the design spectrum according to Y, specifying the value of the coefficient of amplification for each of them depending on the period. Below, we see a table with the participation coefficients and the percentage of mass displaced in each direction of the analysis for each mode of vibration. The total percentage of displaced mass must be a high and significant value, higher than the required minimum percentage of displaced mass. Finally, we can see a representation of the modal periods on the design spectrums.